Director at Honeywell Federal Manufacturing and Technologies. In his role, Dr. Jungk is responsible for developing technology initiatives and providing direction in technology-related issues in support of the company's goals and strategies. And he has authored or co-authored more than 18 peer-reviewed journal articles and conference proceedings. He's an adjunct professor at Missouri University of Science and Technology. He has a BS in Materials Science and Engineering from Washington State University, a PhD in Materials Science and Engineering from University of Minnesota, an MBA from Rockhurst University, and has more than 20 years of experience supporting of national security and defense research and development. And I am pleased that he's going to be talking to us in the section here today about the Kansas City campus and to hear what's going on over there. So thank you very much, and the floor is yours.
Thank you, Jeff. Thanks for the introduction. As introduced, my name is John Jungk. I'll get off the first slide here, hopefully. And so the outline for today's talk, I have about 25 to 30 minutes worth of content. I'm going to give a really quick overview about who I am. Jeff, I think, covered that pretty well. I'll talk about what it means to work at the Kansas City National Security Campus, kind of the breadth and scope of the work that we perform, the customers that we support. I'll spend a little time talking about Honeywell. And so Honeywell, we are an M&O contractor. Honeywell owns the contract for the work that we perform in support of our national security. And so I guess, I'm not going to spend any more time. Jeff, I think you did a great job on the introduction. I'm a material scientist by training, and so I tend to have a soft spot in my heart for material science. I'm fond of saying that everything is made out of materials, and so we need to have a firm understanding of what materials do, and everything's made of materials and interfaces, and so that's certainly relevant to our map. All right, so our mission, kind of an overview, is specific to our site. Every day, more than 5,000 employees come to work at our Kansas City National Security Campus, and so we are an M&O contractor to the Department of Energy, and the work that we perform is directly related to national security missions that ensure the safety, security, and reliability, primarily of our nation's nuclear deterrent. And so our main scope is around manufacturing components that go into nuclear weapons, but we also have additional scope, and we leverage our same skills and capabilities to address other national security applications. And together, through this, we solve complex problems and generate cutting-edge solutions that shape the future. All of that is a way of saying that we use really smart people to solve really hard problems and really critical problems that directly impact and are directly utilized by our nation in support of national defense and national security. I have a YouTube video. I'm not going to spend time on the YouTube videos. If anyone's interested, they can go to YouTube, type in KCNSC, and there's a range of videos we have. This would be an introductory one, but we also have videos performed by our scientists in the labs, by our chemists, and they walk through a couple of things. And so I'd encourage you, if you have time, go out to YouTube and check those out. There's some good videos there. So the Kansas City National Security Campus is a subset of Honeywell FM&T. And so we have multiple locations across Kansas City. We moved from a Bannister location in 2012 into our new Bots facility. And so you can kind of see it from a location standpoint. We have our primary location is about 1.5 million square feet across 4 buildings. So building 1 would be an office area. Buildings 2 and 3 would be our main manufacturing centers. And then building 4 is a separate secure SCIF, a secure compartmentalized information manufacturing space that services some of our other government customers. Since that time, since we moved into this facility, we've seen tremendous growth. And so from that, we've grown into an office building at KCNSC South. And so we house about 100 people there. Then we went west, and we have about 350 to 400 people who sit in a middle area or non-classified office building out there. We recently moved into a KCNSC North, which is, again, about another 350, an office space of about another 350 people. And incidentally, our modeling and simulation team sits up there. And then just to complete the compass, we are currently in the process of expanding into what we call KCNSC East, which is going to be a combination of some office capacity, but really a significant addition to light manufacturing. So a little over 100,000 square feet of manufacturing, a significant fraction that is going to be engineering and agile engineering R&D development space where we can do R&D, really foundational concepts all the way up to product definition before we turn things over to our production side. So from a high level, we are a multi-mission engineering and manufacturing enterprise, really focused on delivering trusted products, again, through that lens of national security products as well as services. We're a leased facility. That's kind of a unique element of who we are. And that was put in place to really avoid the costs of construction, having to spend and set aside, for the government to set aside, hundreds of millions of dollars to build an infrastructure. We were able to lease an infrastructure, spread that cost out over time, and save the government a lot of money that way. And our annual budgets continues to grow. I think in this year we are about $1.6 billion, but we see continued growth in that space over the next couple of years. And I guess another relevant thing is the timelines that we tend to work to are decades. And so we are looking out, certainly 1 to 2 decades into the future, seeing how work flows in and flows out. And so while our budgets are never secure, we certainly are subject to congressional approvals and notifications. We tend to have long time horizons and relatively stable workforces and work scope in that space. So our mission, like I feel like I've hit on this already, is really to support national security objectives through exceptional solutions, effectively managed operations, and targeted services through really talented people. And so the talented people are both experienced experts as well as fresh outs coming out of school. And so people coming in out of school have unique perspectives, they have training and they don't have some of those built-in mentalities that those of us who've been working for 20 years tend to accept as status quo. And so really the integration of new talented people is foundational to helping us grow and get better. But those mission priorities, again, the NNSA is our primary customer. The first one certainly is a safe, secure, and effective nuclear deterrent. Next to that, though, and what plugs into that are strengthening our science, technology, and engineering. And so in my role as the Chief Technology Officer, a big part of my job is to understand how do we identify, how do we incorporate new technologies, new capabilities, and perform applied R&D, put together plans to understand how our material is going to sunset in the future, and how do we import and incorporate new technologies like additive manufacturing? How do we incorporate new manufacturing ways that help us be more agile, be more responsive, and or replace sunsetting materials? So lead solder, anyone who's ever done any soldering, lead is a beautiful material, right? It has a nice low melting point. It works really well. It's very stable, but it has one fundamental problem, and it's made out of lead. And so you can't get rid of them, right? So at some point, environmental regulations are going to sunset that material, and we as an organization and as an enterprise need to know how to respond to that. And so we're making investments in, what are silver solders, tin solders, and how do we incorporate those technologies that are going to work in the products that we make that have really aggressive requirements. They need to be in service for 30 or 40 years. And so understanding how products age and change really is foundational to strengthening our science and technology capabilities. We also look at modern infrastructure, something that's very important. And then that reducing global threats and strengthening our enterprise is a nod to a lot of the work that we do with other government agencies. So we roll up through corporate Honeywell. So Honeywell is the M&O contractor to the FM&T contract. This is just some brief numbers about who Honeywell is. It's a large Fortune 100 company. They're on the New York Stock Exchange. We specifically at FM&T roll up through aerospace. And so we're part of the aerospace segment, but Honeywell also has a building technology segment, a PMT, performance management, or performance materials and technologies, as well as a safety and production solutions branch. And so the way that we leverage that larger Honeywell enterprise is through what we call corporate reach back. And so if we have some question, we reach back into experts in PMT or in aerospace to help us understand and be able to incorporate some of the commercial best practices that they've developed and apply them into the work that we do in our space. So this is kind of a capture or a screenshot of what the whole National Nuclear Security or NNSA organization looks like. We sit right here in the middle. So Kansas City National Security Campus is a production agency for the NNSA, and we partner with the design lab. So Sandia National Lab, Los Alamos National Lab, and Lawrence Livermore National Lab, who have kind of the design responsibility for the products we make. But we partner with them early to understand what those products need to look like, how we're going to put together production strategies. And so certainly working, across the entire country with those design agencies, both in the manufacturing space as well as applied science and technology. And a lot of our products go out to other sites. And so Pantex would be where a lot of the final assemblies occur, Savannah River in Tennessee is where other kind of non-nuclear or nuclear parts are made. And so all of those then get integrated. So this is really what this national picture looks like. But I'm pretty fond of saying we sit right here in the middle of the country. A lot of the work that we do is foundational to, and so we make non-nuclear, all the non-nuclear components. So that is things like radars, it's things like electrical systems, it's things like strong links, which are hot, for lack of a better word, a fancy light switch. It's a mechanical switch that holds off current or holds off the ability to pass through energy or signals unless it's got the right kind of inputs. And so in an accident scenario, a strong link would hold off the ability of energy to move in and hold off a potential unintended nuclear detonation. So a lot of those manufacturers, like 85% of the components that go into our weapons are manufactured out of Kansas City. All right, so around our workforce, and so this data is as of December 2020. We've actually grown since then. We're about 5,500 people, not quite 4,000 are salaried. The other balance of that would be represented or part of our union workforce. But inside of our workforce population, we have a lot of degrees. And so we, kind of in the warm up to the talk today, we were talking about degreed individuals. And so we have thousands of bachelor's degrees. We have, not quite 1,000 people with a master's degree. And so that graduate degree really is something that we value, that extra educational experience, that technical acumen is something that is important for us as we work on some of these really challenging problems. And then we have a handful of PhDs. And so certainly not as many PhDs as the national labs have, but having PhDs helps us in collaborations, helps us in an understanding from where, kind of the advanced concepts that they're coming up with and putting together robust R&D strategies to mature technologies and manufacturing readiness, as well as to be kind of peers in some of those advanced concepts and advanced aspects. And so one of the bigger challenges we're facing is that with tremendous growth, most of that growth is most easily accomplished by hiring people out of school. And so you can see in this pie chart, we're at, I think, over 65% of our staff, and again, this is a little bit dated, but over 65% of our staff has been on our site less than 5 years. And so this is a little misleading in that some of those people that we're hiring do come in with external experiences. So these are less than 5 years of experience at our site, not less than 5 years from, whatever their last degree was. Nevertheless, I would say the bulk of those 63 or 65% tend to be fresh out grads. And so, bringing in lots and lots of new talent into our business has been a challenge because we need to make sure that we're incorporating, kind of the right mission, who we are, and translating our culture to them. And so incorporating the elements of the culture that they bring with them around incorporating new ideas, being agile, but making sure that new people understand the constraints and the balances that we have in the work we do. And so, and then, kind of the balance of this pie is around people with 5 to 20 years, and then more than 20. And so interestingly, today, we had a person retire who had been at our site for 52 years. And so 52 years of experience, he retired out of our analytical labs. And he was actually one of the people that brought gas chromatography to our site. And so he brought the first GC in. And so he retired today, and it was, candidly, from a personal note, it was a sad day to see him go. but I'm excited for him and appreciate the work that he did. But we're losing as this chunk leaves. Those are the people that we look to train and develop. Kind of all of these people that are coming in. Nevertheless, the takeaway is that we're continuing to grow, right? And so for undergrads coming out, for grads coming out, there's continued demand for their capabilities and their services at our site. So who are we hiring? What are those typical positions? And so on this slide, I've broken them down into roles, not necessarily degrees. And so the roles that people would hire into would be a product engineer. And so a product engineer would be the owner of the product that we would make. And so, for example, if we were trying to manufacture a pencil, they would be the engineer in charge of the product requirements or the definition of what that pencil is, kind of the diameter, what the materials were that it was made up of, kind of its dimensions and any specific characteristics or attributes that it had. Underneath that, we have process engineers. And so from a product engineer, those product engineers are double E's, mechanical engineers, chemical engineers. It really depends on what that product is. And so we have, for electrical products, we tend to hire electrical engineers to be those product engineers. For things like cushions or pads or things that have a strong chemical components, we tend to hire chemists or chemical engineers to be those, or material scientists to be the product engineers. So the product engineer really references or leverages the educational background of who that person is and where they're coming from. Underneath that, we have process engineers. And so these are the people, if I go back to my pencil analogy, would be interfacing with our manufacturing operations to understand, okay, I know what my product requirements are because I talked to the product engineer, but how am I going to make that pencil? How am I going to cut it to the right size? How am I going to make sure that I'm molding it in the right way that it ends up meeting its ultimate product need? We also have purchase product engineers, so a significant fraction of the materials that we bring into our site are purchased. And so we, things like O-rings, but even we even procure and purchase more complicated assemblies. And so we have an organization that really specializes in going out, working with vendors, building the capability of our supply chain and our supply base, and making sure that they understand kind of the rules and the requirements of working with us and how we can procure their services in a way. So how do we leverage commercial best practices outside and then use that to build a robust and stable supply chain of materials on our site? Certainly supervisors and managers are roles that we hire into. Materials engineer, again, like I said, that's a special place in my heart because that's my training, my background. But I would say that encompasses in that buckets chemists, chemical engineers, physicists, even mechanical engineers in some cases would fall under the bracket of what a materials engineer would do based on their role. And so that's a lot of aging and compatibility testing, analytical testing in our analytical labs, in manufacturing using some of our chemical synthesis routes or routines would be materials engineers or chemical engineers we would hire. We hire industrial engineers, and these would be people that we would come in and help assess kind of the manufacturing flow, oftentimes applying Six Sigma tools or lean manufacturing operations to identify ways for us to be more effective there. Test equipment engineering is a big important element for us. And so this is one of the unique spaces where we actually have a lot of the design responsibility, where we build and manufacture our test equipment. And so there's both a hardware component as well as a software component inside of that. And so a lot of double E's, a lot of software engineers, and candidly, a lot of mechanical engineers also. So if we're trying to interrogate or test a mechanical response to some component, we use mechanical engineers in that space. And then environmental and non-destructive. And so things like CT scanning, thermal responses. We have large centrifuges that we'll put components through G loads or shake like halt or HASS testing. And so lots of demand for there. And then underneath all of that is our quality organization. And so really all of these roles and titles can flow into our quality organization that looks at how are we ensuring that our products are meeting our product requirements, and how are we testing that in a way that is robust and stable. And so here's where I'm going to take a bit of a slant from kind of the standard slide deck and talk about some specific capabilities and specific manufacturing we do that's relative to chemical and chemistries. And so we have a space called special materials production. And this is where we perform chemical processing, we do sample preparation, we also do down packing. So we bring in large packages of chemistries or materials that are made outside of our site and down pack them into smaller containers. But we also do our own on-site manufacturing. So we make over 70 custom materials on a reoccurring basis. In fact, our library is larger than that on a non-reoccurring basis. I think we have 250 or 300 chemicals that we can make, and 70 of those that we make relatively frequently. But at least at the time that we made these slides a couple of years ago, at that time, all of our processes utilized batch production processes. And so big batch reactors going from smallish 20-gallon up to 500-gallon reactors with this one-size-fits-all production expectation. And so if I needed 8 gallon, I'm making 20, or I'm making 50, or I'm making whatever that recipe calls for. And then I need to figure out what to do with the rest of it. So am I storing it? Am I throwing it away? And so we had this this one-size-fits-all drove a lot of additional storage of materials. It also drove kind of this, hey, I'm going to make it once a year, and then a whole year goes by before I make my next production run. And so there's some kind of ebbs and flows in those production sequences. And so the other challenge was that as new materials came in, we wanted to incorporate making new materials. So, for example, if a supplier's, if one of our procured materials in our supply chain, they said we're not going to make that anymore, we would have to either find another source out in the supply chain, or we would need to make it ourselves. And so, kind of going through that pilot scale-up operation, that's it can take a long time and slow, and it can be relatively slow and require some complex scale-ups. And so, we started looking into how can we be more agile in this space? What are technologies that we can adopt that help us understand both chemical manufacturing as well as address some of these scale-up issues? And so one of the approaches we took, we started this work, I think in about 2013, was around using microfluidics. And so these are small-scale flow reactors, really taking advantage of I think some combinatorial material science. And so a lot of this work was done in pharmaceuticals, but also a lot of the same equipment that's used in like liquid phase chromatography. So small pumps, pushing chemistries through glass slides where you get really high mixing, really efficient mixing. And so we applied this to a peroxide synthesis. And so this case happened where we had a supplier who was the only source that we had and the only source in the world for a unique peroxide, said, we're not going to make it anymore. And they told us that. And so we went out and we bought all in their supply. But then we looked at making it in batch reactors, and peroxide synthesis, as I'm pretty sure people on this call are aware, it's exothermic, right? And so if you aren't careful, it can get hot. It can, the exothermic reaction can drive the reaction rate, and it can cascade and run away from you. And so when we explained that to our site leadership, and that what a cascade reaction in peroxide synthesis essentially means, a hole in the ground where your building used to be, they were like, well, that's great, we're not going to do that. And so we had to figure out, okay, how else can we make it? Because this chemistry was critical to the manufacturing process that we had, and it would have cost us millions of dollars to qualify a new process or new chemistry. And so we looked at this microfluidics as a way to address that. And what we demonstrated in really just inside of a couple of years is that we could make this chemistry using flow reactors, and I'll show you the reactor in just a second. And it was per NMR, the same molecule. So structurally it was the same. And through liquid phase chromatography mass spec, it had kind of that same activity level. And so really we were making the same molecule as what our customers were making and what we had sourced before, using this flow chemistry. So qualification of that chemistry, qualification of the molecule was very simple in that we could show kind of this background. And so this slide says they've given approval for use this year. We're actually now in production with it. And this is what the reactor looks like. And so it's etched glass, and we flow the chemistries through it, and really with milliliters of volume. And so the advantage here is if you get a runaway reaction, instead of a hole in the ground, you have a piece of cracked glass. But the reality is that with this sort of situation, you can pull heat out faster than it can accumulate. And so you can do a whole bunch of really interesting things around real-time IR monitoring. So as chemistries are flowing by, you can have IR detectors monitoring in situ while you're making it. And so if your process starts to drift on you, you can control temperature, you can control flow rate to bring things back into specification. And so, and the other element is that we can, from a production volume, you can either, from a scale-up perspective, what we call it numbering up. And so if I need more capacity or more output, I could just add 2, 3, 4, 5 of these reactors in parallel and achieve, essentially production rates that are at or greater than what I was achieving in batch reactors. And so this is a really kind of emerging technology that we demonstrated again in the early kind of 2014, 2015. We're in production now. On this material, we're qualifying another material that's actually a solid, and so we've timed the reaction so that it crashes out a solution right at the end of its process or duration inside of the channels. And so it's a really, in my mind, agile and innovative way that I can make materials on demand. It enables me to reduce my supply chain risk, and it takes advantage of PhDs and scientists and chemists coming out of school, helping us figure out new synthesis routes to make some of the materials that we use in our supply chain and in our production spaces. So this is really a slide around inline processes, and so I'm not going to spend that much time on it, but we're taking and we're scaling these processes. We're incorporating efficiencies inside of them, and these are some of the newer technologies since 2014, 2015 that we're evaluating now to help drive even faster rates. And so you can't have any good technical presentation without the acknowledgements. And so these are the people who did all the hard work, both on the polymer side, the material science team in red, and one of our experienced scientists forgot his red jacket on the day of the picture, and then our manufacturing team on the other side. And so really strong support from the intersection of materials, working with manufacturing. They were working in the same spaces. You can see that's the same lab. And so we had handoff from the materials team to the production team is essentially putting things on a cart, rolling it down the hall and plugging it in, and as opposed to having to go through scale-up operations. And then definitely support out of our analytical labs as well. Okay, that was the short tangent related to chemistries. I'm going to pull it back to continue the kind of the macro level. And so as we bring people into our site, we recognize that the skills that they come in with, that education and learning is a lifelong activity, not necessarily one that you're going to stop doing once you start working. And so we have a range of educational and targeted opportunities as people come in. And so one is around the technical fellowship program, and that's around people coming in with bachelor's degrees that we want to target to go get primarily master's degrees, but we've actually used this in the past for PhDs to go and be a full-time student at a school who excels at some technology that we have a gap in. And so this is a place where we want to make a strategic investment where we know that a person's going to be gone for 2 years while they're off getting a master's degree or finishing the last 2 years of their PhD. But that's something that enables us to pull in really good talent, because this is a benefit, because you keep your salary, it's really you continue to get paid, but you get to go be a graduate student at school, and so you get to be it's a capability for us to go pull some really good talent. The other thing we have is a weapon intern program, and so that's not a graduate degree or a school degree, but it's a very targeted program, a focused program that occurs at one of our national labs, where you go and essentially have a deep dive and a deep study into the history of nuclear weapons. And so you understand kind of the arc of what nuclear weapons are and the technologies that have gone into them. And so coming out of that, you have those students have a strong understanding of what it means to qualify new weapons, what future systems are going to need, themes around nuclear safety. And so they can come in and provide very focused and targeted inputs into our production spaces to say, hey, here's what our design agencies are trying to do, and here's how we can maybe manufacture those more effectively. We also have a rotation program for new hires. And so as people come into our site, you can be a part of this new hire engineering rotation where you spend a couple of, so 6 months or 12 months in several different parts of our business and really get to see kind of a broader expanse of what it means to be a product engineer, what it means to be a process engineer, what it means to work in the analytical labs and perform analytical testing. And so you get kind of that holistic understanding, or these students get that holistic understanding of kind of how the different pieces of the business fit together. We also have residencies, and so residencies both in DC as well as at national labs. And then for all of our staff, we have an educational assistants. And so for people who are working on a bachelor's degree, we pay for we pay, up to, a little over $5,000 a year on their bachelor's degree. It's actually a little bit more than that if people are getting master's degrees. And so really encouraging people who come in with associate's degrees to go and continue education in a field that makes sense to them or that they're interested in. So from a culture perspective, I know we're probably running out of time here. We tend to pride ourselves on work-life balance. And so we have flex time. We have a 980 option. And so what that means is you work 9 hours a day, Monday through Thursday, 8 hours on Friday, and then every other Friday you get off. So it's pretty nice to have a 3-day weekend every other week. We have a relatively stable work environment. And so like I talked about, the funding profiles that we have tend to work out over decades, but dynamic in that you can come in as a product engineer and then you can rotate into be a modeling and, go and work in modeling and simulation. And then you can rotate. So you can have a diverse career inside of underneath the same roof. Lots of technology and equipment. So that's something that sings to me is around a focus around applied technology, applied R&D. And then, like I said, we have a history of long careers and friendships. And so my good friend who retired today, and then competitive benefits. And then we have this winter shutdown, which coincides with kind of the Christmas, New Year's holiday. So at the end of each year, our entire enterprise essentially shuts down for about a week. And so it's nice because you get to go on vacation and don't come back after a week with hundreds of emails that you then have to respond to. We also have sports and clubs, and so we participate in corporate challenge. We have a fitness center on site, and so really encourage people to have a life outside of work versus just coming in and living inside the walls. So we also have a strong community commitment, and so we directly support employees to go and spend up to 40 hours of paid time to go volunteer in their community. And so things like Knowledge Bowl or Science Olympiad, we'll support and man some of those activities. And so that a way that we can, really give back and integrate inside of our community. We have a handful of awards that you can see there and key activities and initiatives that we tend to support every year. So First Robotics, we're a big participant in First Robotics. Harvesters and Makerspace is something else we really do. And so that's the end of my formal talks. I'd encourage you to, please share these with your staff, with other interested people. You can connect with us. And then if people are interested in jobs, there's a website, kcnse.doe.gov, links directly to openings and applications that we have on our site. And at this point, I will open it up for questions. I will stop sharing my screen.
Well, thank you very much. That was very nice. I have a question about what your advice might be to a student, say maybe in their second or third year pursuing a bachelor's degree in chemistry or biochemistry or something in that field. What would your advice be if they were interested in a career along this path?
Sure. So a couple of things. Talk to your professors, because professors oftentimes have lines in internships. Internships is how I got started. I started at Washington State. That's my alma mater. In my sophomore year, I did an internship at Virginia Tech, and that really, got me kicked off on the career and the course that I'm on today. And so internships are a great way to kind of dip your toe in the field of some of these manufacturing. Co-ops are another one. And so internships tend to be short summers. Co-ops are a little bit longer. But get engaged, and you don't have to also go do an internship. Oftentimes professors have some work study that they're trying to do inside of their labs. And so if you're interested in research, the professors at your side are certainly the easiest forum into that. But internships, I know when we're recruiting or we're interviewing people, I look for internships. I like to see kind of, where have you been? What have you done? And then, kind of talk me through what your internship was. What did you do to, kind of to broaden just that academic experience. Another thing that I look for are, is working in a lot of those student activities. And so for mechanical engineers, oftentimes we'll look at, are the students involved in their like SAE automotive clubs? Are they, part of a rocket club? Are they part of, what are they doing that's not just solely focused on academic excellence and academic achievement? I like to see some breadth in kind of getting outside of that.
Okay. Also, are there things that a professional society like the ACS or the Kansas City section of the ACS can do to help your mission at Honeywell?
Oh man, Jeff, I totally should have thought of that question before. So candidly, I think a lot of what you guys want to do is be advocates for people in our careers. And so I think probably, doing that is doing the job. Certainly I'm more than interested in being able to advertise who we are and what we do. But I think being good stewards, being able to champion kind of the things that we care about, what opportunities are in our region. I fully appreciate that not every chemist or chemical engineer is going to want to come and work at Honeywell. And we have lots of, a diverse ecosystem in our space around where people can go. And so as much as possible, we certainly want to keep them in our space. We don't want to train people and then, export them to the coasts. But so being stewards and articulating, kind of what all of the advantages are in our region, as well as what all the opportunities, I think is part and parcel of what your chapter can do.
Okay. All right. Well, thank you.
John, Gary Clapp. We had the challenge of working with some pretty nasty materials in the past, but one of the problems we've had when we move from development to process development from maybe research is the handoff sometimes occurs. Does somebody from the development group go along with, or the research group go along with the development group to make sure the handoff occurs effectively?
Yeah, Gary, that is a great point. So handoffs in technology are critical. That's in fact one of the strengths of the microreactor example I gave, is that the handoff is so easy because you're just essentially kind of rolling the equipment down the hall, and so the production space buys the exact same equipment and they can pick things up very quickly. But you're right, if you don't account for that handoff, you're going to run into problems. And we certainly have examples in our history of where design came across and it was, a bunch of work happened in the lab and it was perceived to be easy, but the handoff was not managed effectively, and then you pay for that on the back end. It takes, you pay for it in cost and in schedule and additional work. So to answer your question, yes. As part of our technology TRL, so technology readiness levels, we make sure that at the time when we're handing technologies, those scientists and researchers are working with the production folks to make sure that they understand it, that they're coming into the labs and seeing it, and then as well as our scientists are actually going out to the floor. And so we have a lot of our simulation experts who spend time simulating capabilities, but they'll go out to the floor and they'll walk the process with our operators. They'll walk the process with those product engineers and process engineers to understand, okay, here's what I'm trying to simulate in the computer, and in whether it's an encapsulation. So if I'm trying to fill a mold with an encapsulant, they go and they look at the physical processes, and then they'll come back, they'll iterate, they'll simulate, and then there's a team that comes in and they do those assessments really as a product team. But again, how you manage those handoffs is very critical.
It sounds absolutely fascinating. I would think that the younger people, if they had a broad view of what's going on there, would be geez, the things we could learn every day would be so cool.
Yeah. One of the interesting elements of our site is we make everything from semiconductors to semi-trailers. And so we have this large manufacturing space, and we make lots and lots of many things. We make many things, but not very many of them. And so kind of the breadth of manufacturing and the breadth of capabilities that we have to execute our national security mission is pretty impressive. And it's great because I get to go to work every day and I'm challenged by, PhDs and scientists and engineers who are doing really great work. But I learn something pretty much every day. Or anytime I get away from my computer and stop doing email, I'll learn something.
Well, we're supposed to be the applied learning institution up at Missouri Western. That's sort of our by statute, that's what we're supposed to be. So I think our people would love to know more about what goes on there. A quick question about maybe something you can't answer, but oftentimes the electromagnetic pulse that accompanies a very energetic explosion of some sort, that disrupts communications in the field. Are these things that are maybe you can't say, but how do we protect our equipment and communications when those things happen? Are there special pieces of equipment that are designed for that, or we have to go back to copper in order to handle those communications?
Yeah, so certainly can't go into a lot of details there, but there's design elements you can go into from a shielding perspective. You would design a product to accommodate or account for that sort of environment. And whether it's a material selection or a design features that incorporate some sort of shielding, active or passive shielding, that's how you would address those sorts of scenarios.
I did some work for Ball Aerospace about 20 years ago. We were working on the ICBMs at the time, and I had to swear my life away in order to work for them. But we solved the problem. And the embarrassment for a company like that is that they couldn't, and they had to outsource it. But we had a great working relationship with Ball at the time, and that was I swear that those days were like you learn something every day. We put new tools on our tool belt, sort of, as we say, every day under those circumstances.
Yeah, was it the Ball out of Boulder?
Yes.
Ball Aerospace out of Boulder.
Yeah,
we're very, very familiar with that company.
Yeah, there was a battery issue, because it had to come to charge within a certain amount of time, and if it didn't do that, it can't shoot down other missiles because it has no guidance system. Then
sounds like an important requirement.
It was, and it was an interesting way to solve it. So we did it. So we showed them what was going wrong and solved the problem for them. Of course, they had to replace all the batteries, but nonetheless,
solve the problem.
Solve the problem. Thank you again for a great talk. I certainly hope after this restriction on travel and things and visiting campuses that you can come up and visit our labs and maybe even do a similar talk to our seniors and juniors and show them that there's a path forward for them. We're certainly going to record this and put it on our YouTube channel and make sure that our alchemy group and our biochemistry group are well aware of what goes on there.
Great. Yeah, I'd welcome the opportunity. And candidly, I'd probably bring some of my technology leadership staff with me to be part of that visit.
That'd be great. Thank you. Jeff, I'm going to cut out because I have 3 jobs to do and I'm not done with them yet.
I understand. I totally understand. Okay.
Right.
Are there any other questions? Any other questions, thoughts?